So it's my honor now to introduce Dr. David Rothschild. David works at Microsoft Research. He earned his PhD in economics from the Wharton Business School at the University of Pennsylvania. I've asked David to take a few minutes at the beginning of his talk to sort of describe the whole field of predictive analytics so that we might have a little context for what the individual speakers after him will be talking about. David is widely published, and he will highlight some of those areas in his talk. His talk is entitled Predictions with Passive and Active Data. David, thank you for your participation. If you would rather follow me with the microphone, you can do that. You can speak Let me ask the guy to bring it up for you.
Thank you all for being here today. I really appreciate the invitation, and I look forward to having a good discussion. And so I do want to open up with a bit of an introduction into predictive analytics. And the way that I structured it today was, rather than really focus very heavily on specific instances, is to take a broader look at some of the major questions that are being tackled by the field, in both academically and in practice. And the way I structured it is to think through the main steps that people need to address when thinking about any predictive question. And this process looks something like this. It's thinking about the question that you want to answer, the question that needs to be answered by the stakeholder, the data that's both available, and then the data that can then be acquired in order to try to answer this question, thinking through the different tools and methods that are available, constantly changing. Oh yes, thank you. Testing 1, 2, perfect. And then thinking through how people are going to consume this prediction, which is a huge problem from an academic perspective, because a lot of people do not consider it past steps 1, 2, and 3, unfortunately, and then ultimately how this feeds back into the system. And I'll start with the question of, start with the question of the question. And the question is one of the most challenging parts of thinking about predictions. And one of the things that's most looked over and least appreciated, because sometimes we take things for granted historically, sometimes we approximate it, but you should always be starting with what is the ideal question for the person or stakeholders that are looking for this. And I'm coming from economics, and the ideal question in economics is always a multi-universe replay of the world, right? So if you're thinking macroeconomics, you want to have 1,000 universes, have them all play out. I mean, these are not possible things, but it's really important to take a step back and think about that, because everything you do is approximating that. And if you don't think towards that ideal, you're going to forget some of the things which are missing in your approximation, because every prediction you do is an approximation for the thing you really want, right? You do need to make sure that when you move past the ideal, that you do something that is solvable. But let me talk about two major shifts. One is that through the 10 years or so since I started or was in my PhD and working towards this stuff, a lot of high-level aggregate predictions were the key. We're seeing this massive shift in the field towards individual level predictions. This makes sense because of both available data and available power in what we're able to do. Time frame has moved from thinking about predictions as kind of this thing that happens and then events happen, to something that works with extremely low latency and continuously updates throughout the process. And these are two things which I'll talk about as we move forward. But let me walk through an example. So I have been very happy to be able to talk with the IARPA team a bunch over the years, as they've done a bunch of different prediction challenges. And one of the things that they've been thinking about is obviously foreign outcomes, which would be germane today. I mean, this is kind of the question I think we want to know a lot of times, and then we need to think through what types of predictions can be solvable, right? So you can't just ask wide open questions. You need to predict things that could be, but conditional predictions are really difficult, because now you're in a world in which you're really doing kind of two different predictions at once, and you're thinking about how do they play on top of each other. So a lot of times you end up with the top and then you end down towards that bottom, right? So you end up asking these two questions separately. Will Assad be in power at the end of a certain date, and will the US withdraw forces? And then you're trying to combine the two together rather than asking that question at the top, which is basically impossible to answer. And let me give you kind of an equivalent in politics. So you could be thinking, what Donald Trump's going to get in the popular vote, but then you don't really ultimately care maybe about the popular vote as much as you care about who's going to win the election. Depends which kind of stakeholder you are. But the real evolution has been moving from kind of thinking about this generic question about probability to maybe a lot more specific subgroups as well. So a lot of the things you'll see out of the 2016 election were people thinking more about how you start breaking it down. And then to single out another speaker later today, you may move to actually individual predictions. And so maybe this subgroup gets a different type of prediction from individual. And of course, as we think about intelligence questions, the ability to start predicting across the globe on individuals is very different than predicting generic subgroups. There's a popular, increasingly somewhat popular prediction market company, Augur, which is based off of cryptocurrency. And I won't going to go into details of them, but I will say that this was the question that they had hundreds of thousands of dollars riding on in a market. So it was a free money, it was a real money market using Ethereum. This question had a couple $100,000 riding on it. And the day after the election, the Democrats obviously won the House, but because this was a poorly written question, it was settled in terms of the Republicans because they still controlled the House the day after the election. And then there was a massive fight, which basically threatened the existence of the entire exchange, and it was ultimately flipped, and it was rewarded to the people who had their money on the terms of the Democrats winning the House. But this is a reminder of how easy it is to screw up and how hard it is to write good questions. Data, of course, you never have exactly what you want. So ideally, we would love to just know everything, right? You throw everything into the predictive model, and all of a sudden things start coming out great. If you're thinking about Assad, maybe you want to know everything about the regime. You want to know everything about the people. You want to get all the opinions of experts. Same thing in politics. Of course, that's not possible. So I'll try to break up data in my mind into things which I'll refer to as passive data, which is data that exists already, maybe not to solve the question you have in mind, but it already exists, and these are things that can be farmed. So in the case here, there's things that we've already collected. There's search and browsing data and social media data that can help approximate opinions coming out. Not great sometimes, but a lot of different representative issues we need to deal with. And then, of course, on politics, we have a huge amount of data coming through the history of politics. Again, this is data that sort of exists and that you can mine and put together. And I kind of put that in contrast to active data, which is then now we're going to go out and we're going to collect more data. One of the key things that we see in this field, and the IARPA challenges were really nice examples of this, is that we have moved a lot in the world of thinking about these two types of data, all sorts of data separately. So there was an IARPA challenge a few years ago in which there was a bunch of challenges on how to actively collect data from experts, aggregate that up. They use prediction markets and they use polls. And then the next challenge was, okay, now let's build some fundamental models and then use updating processes to only engage experts where it would have the best marginal benefit, right? And so rather than thinking about, oh, I have these fundamental models and now I have these active models, let's think about how we have a really nice updating process in which we find the most cost-effective way to engage people only when it adds added benefit. And of course, there's a bunch of different things you could be doing, even in hostile countries in which we can be gaining additional data from experts or even people in the country now using various technology, which I'll touch on later. I need to update some of the slides I was added in, I realized this morning, but there's a lot of tools that have come off. But I think about appropriate tools. Increasingly, it's moving things from computers to cloud when it comes to polling, merging, and cleaning data, which is, for every data scientist, is like 90% of the battle. And that is the challenges have become increasingly easy in some ways because of the way in which we can handle and access data, but also somewhat complex in the choices that we have. And statistical analysis has obviously moved forward in various ways as well. And when it comes to appropriate methods, the first thing I learned in my PhD program, really that I remember so substantively, was my advisor yelling at me that if you can solve a problem with a simpler method, you should always do that. And we always want to try the most complex and interesting methods to both demonstrate our strength as a data scientist, as well as in order to test the bounds. But obviously, there's a lot of really simple things that still work in predictions, averages, simple regressions, before you start moving into machine learning and deep learning and the necessary ways to parse the data. Just a few points. Obviously, basically setting up the question is going to make things easier. Well-framed questions make it easier to both determine the method and solve them. And then ultimately, one of the big challenges as economics and computer scientists have kind of come together over the last few cycles, which have been a really exciting thing for me in predictions, is kind of different views of what exogeneity and causality really mean. And for economists, what this means is that we are talking to computer scientists about a holdout set of data. If you have X data and you take 1/3 and hold it out, that only works in predicting things if the data is stable. So you add the element of time and you add evolving ways in which data is collected and what it means. That type of holdout set doesn't work because it doesn't predict the future, it predicts the present, basically. But on the flip side, of course, economists have learned a huge amount about the idea that you don't always need structure in order to make predictions, because that was what was holding us back. So economists were like, we need to be able to draw a model, and that model basically limits the variables we can use. It limits the complexity of the method to things that we could actually understand. But sometimes you can just throw a random forest at it and it solves it, and that's great. Maybe we don't fully understand which variables are driving it, but that actually could give us a more accurate prediction. And so this is a really interesting give and take that's happened over the last few years. And so I'll touch briefly, coming from academia into a more practical world, I was always struck right away is that basically everything in academia sort of ends at step 3. People don't think about then how people ultimately use predictions and how that feedback loop is important in understanding what happens. And I'll touch on kind of, I always like the grammar rule, which is that if you can't explain what you did, then that's probably a problem for everyone. But clear direction, obviously, once you start handing predictions off to people, you end up with bad principal agent problems. People want clear direction. They don't want to hear about nuance. They want answers. They also sometimes want you to reinforce their prior beliefs, and these can be tough challenges because there's a lot of pressure on that. So it's always really important to keep in mind what is correct and what we really have. And then, of course, there's a whole host of questions that both, everyone's facing in academics and practice in the intelligence community. There's questions about privacy and security, but I would extend it further to a lot of questions about where the data comes from and what we should think about and how that has further implications for other things in society. And then finally, I'll kind of end on this on kind of a question about return on investment, which is that, of course, we make predictions. We do all of this in order to impact something. It's easy to think about accuracy. This is always the first thing that we want. If you publish an academic paper and you're like, it costs $1 billion and it increases the prediction by a statistically significant epsilon, people would be like, great, you're published, even if it has absolutely no meaning. But obviously, there's other things, other metrics we want to also always consider. With any market intelligence or any sort of intelligence, the speed, the scalability, the relevancy to ultimately stakeholders, but then also, not just the prediction itself, but what is it affecting and what choices are affecting and what is the marginal impact there. That's much more important. So if it's leading to allocation of resources, if for advertising campaigns, really easy to think about. So in politics, if you put money here versus there, what's the marginal impact? But that's much more important than the prediction itself, because that's why you make predictions. And then ultimately, how does the data flow back into a system and make everything better again? So how does this essentially create a righteous cycle of better predictions and better investment over time? So that would be my introduction. Thinking through these things hopefully will help you in all of the talks ahead, thinking about where people are going. And then let me jump into my main talk. As the introduction, my name is David Rothschild. I am an economist at Microsoft Research in New York City. And in the same frame as we were talking about. I answer questions along a varying types of things. So first kind of bucket of stuff would be around predictions and public opinion and roughly kind of in the market intelligence framework. I also do a lot of work in understanding paid and earned media, both the kind of market for it and then ultimately how it affects public opinion, so thinking those two together, and then more general kind of behavioral economics and finance questions, especially around market design. And the type of data that I am familiar with, things that I have published academically on, large administrative data sets, large behavioral data. I've had a lot of time with Twitter and Facebook and other social media data, browsing data, and search data. You may not know this, but actually Microsoft owns a search engine and a browser. I'm sure all of you are using Bing on Edge in order to get your latest insights about the world. Market design work, actually building out different types of markets, so option markets and future markets, and prediction markets in particular. And then a lot of work on understanding increasingly changing idea of what a survey is and how we build and analyze that data. And I'm going to center my talk here around elections, and I probably a little crazy, so I apologize if some of these are a little messy, but I decided to take a look back for today's talk and actually create a new talk in which I kind of think about how things have evolved over the last 8 years. And this was actually really helpful to me because it helped me think through some of the things that people are doing now and how it's differed and what I should expect moving forward in a more clear way. And I'll focus it in the same way which I kind of focused the introduction, which is thinking about questions and then data and then the analytics methods. And so thinking back to 2012, and I had a good time looking at some of my talks prior to the 2012 election and right after, and some of the things we published. One of the things that was happening then was really the shift into thinking about which type of question we were trying to answer. So moving away from thinking about kind of popular vote, which was the standard thing that people were implicitly predicting by just putting polling out there, into thinking about probabilities. And then one of the things that I had spent a lot of time on then is and as I do now, is thinking about combinatorial probabilities. This is important for everything. It becomes particularly important in politics because the ultimate outcome is a combinatorial probability. So we can predict the 51 states independently, but since we have an electoral college, which is a collection of 51 different outcomes and how it comes together, that is a combinatorial outcome, and just it is 2 to the power of 51 possible outcomes technically, although a lot of those verge towards 0. And target populations at the time are thinking a lot about state level outcomes, and most importantly, and as I'll talk forward, thinking about these types of data distinctly, actually published at various times, different predictions for some of the same outcomes using 6 different types of data, which at the time we were kind of treating as kind of very different and not so much at this point. And actually, I'm not sure how maybe I can't go back. Oh no, I can go back. So just real briefly, kind of fundamental data. So this is data that is kind of basically just there and you're mining, biographical data, vote history, et cetera. Some experimental polling, which I'll explain, in which we were basically manipulating both the question and how the analytics we did. Prediction markets, which I'll explain a bit for those who are unfamiliar with, and adjusting in various ways. And then online and social media data, which was an excitingly new thing in 2012 to deal with. So fundamentals. So like many people, we came out in 2012 with fundamental models, which are basically saying, what can we do with just existing data outside of, in this case, even polling data? And the outcomes we looked at were state-by-state estimated vote share and state-by-state probability of victory. We used these 6 things: approval, incumbency, past election results, economic indicators, ideology, and biographical information. There's a few interesting things that come out, and I would point out, for me, fundamental models are extremely important for not just predictions, but understanding how things correlate and what we should be thinking about in terms. So for example, on economic indicators, we tried things any possible way, and we showed that movement in state-by-state economics somewhere between the 4th quarter of the previous year and the 1st quarter of the election year were the key indicators as far as having predictive power. And what that means is that people's minds basically become set pretty early, and that late movement in economics is not going to shift people and how they're viewing the shift in their state. State-level economics at the time was still very valuable compared to maybe national trends, et cetera, and some other things from there. We put this up onto Yahoo, where I was working at the time. In February of 2012, we said Obama was going to get 303 electoral votes. This was the map that came with it. We had Florida ultimately went to the president, but so otherwise looked pretty good. So pretty low error, pretty low, pretty high correction, binary correctness. So this was great. We were really excited. So this came out very early, but of course we're still looking at how the election was evolving. These fundamental models essentially are comparing a generic Democrat versus a generic Republican, but we don't have a generic Democrat or generic Republican. We have actual ones. We went onto the Xbox and we asked non-random people to log in and just say who they were going to vote for. And we did this throughout the election cycle. And if you look at the dotted black line, that's the vote share that President Obama got. If you look at the kind of vertically dotted dashed line, that's what pollster.com, that's the aggregate of all publicly available polls had. And if you look at the red line, this is what the raw Xbox numbers look like. So this is the data we got in every day. If you're wondering, there's a lot of young people on Xbox, but there's like a ton of men. So that was the dominant factor. So the men voting Republican was much more important than the Xbox. Actually, the time, this was a naiver time. We were not as worried about kind of the right-wing fanaticism that's now happened inside gaming systems, which is a completely different story, which I could talk about later. At the time, this was really like, oh, okay, that's interesting. Now we'd be like, yeah, of course, all the gamers are right-wing. But then we ran it through an analytics system every day in which we were adjusting for the representation. This is what we were putting out on a daily basis. We felt pretty good about it. And ultimately, you can see the state by state where we had the trends over the last few weeks using this Xbox data, massive data. We basically were correcting for various types of demographics. This work, which I'll talk about further in detail when I talk about move forward to 2016, has now become a heavily influenced in how the whole polling system works and how they do handle raw data. There's a second thing which was very related to it, but rather than doing post-analytics, we were thinking about the questions we were asking. Surveys have been very static for a very long time. We ask very simple questions. We get answers which are interesting, but maybe not the most useful. Think about this question of who you vote for in the next election. That leaves a lot of data on the table that people know. You're not really mining people's knowledge of elections as effectively as you could if maybe you asked them predictive questions. So we got out there and said, okay, maybe we'll ask some predictive questions. We had a bunch of historical data that showed that when you ask people at the same time who they intend to vote for and who they expect to win, that the predictive questions were actually more accurate than the voter intention questions. This was all not doing post-analytics, though. This is representative data. And that when they disagreed, made sense. About 75% of the time, the expectation pointed in the right direction. So we asked the same totally non-representative people who they thought were going to win their state. And we also put this forward, too. And we had 51 out of 51 states pointing in the correct direction by simply asking people who they thought was going to win their state. And also put this up prior to the election in various places, including this article in Huffington Post, New York Times piece on it. So we felt pretty good about that. Interestingly, for those of you who are survey aficionados, the kind of thing that started the entire modern survey field was in 1936, the Literary Digest just went out and asked essentially about a quarter of all voters, because they had a pretty large reach, who you're going to vote for in the next election. They had Landon in a landslide. So that was bad, and this was embarrassing. The exact same time, the New York Times asked experts in each state. They just did a small expectation poll in each state, had Roosevelt winning in a landslide. So at the same time that kind of opt-in, no analytics survey gave way to Gallup's concept of random and representative people being asked questions, and then ultimately his analytics that kind of came forth in the 40s and the 50s. Simple expectation questions to smaller groups of people was already being shown as a way that you could look at elections and figure things out. All right, let's take a fourth thing that we're putting out is on prediction market data. So prediction markets are real money markets, and that you could essentially buy and sell futures contracts, which canonically would be worth $1 if something happens and worth $0 if it does not happen. And so these contracts have evolved in various ways, but ultimately you can think of them as approximately, the price is approximately what the market thinks is the probability of something happening. And so you'll see on the left here, this is the polling averages for the GOP primary in 2012. It was quite topsy-turvy with Romney bouncing back and forth between Perry, Kaine, Gingrich, a bunch of other people. But the prediction markets kind of just went away with Romney during the entire process. And so it provided a very, very clear demonstration, whereas the polling was quite convoluted because the prediction markets were looking at the polling and then obviously factoring in other information. And during the election cycle itself, prediction markets did quite well. I was actually looking at a talk I gave just 2 or 3 days before the election in which Obama was down in the polling averages at the time. So you may not remember this, but even very late in the cycle, the party polling averages up until November actually had him down, but the prediction markets continuously had him up and away. And so they were looking at the same data and providing an interesting intake at the time. For those of you who are fans of the site 538, I did a paper at the time in which we looked at the state-by-state predictions coming out of 538 as an example of polling averages turned into probabilities, compared that to what we were getting from state-by-state data coming out of prediction markets. Above the line would be prediction markets having a lower mean squared error. Below the line would be polling have a lower mean squared error. And what you basically could take away from this is that polling and prediction markets essentially converge towards the end of an election cycle as polling becomes the dominant input into what basically traders are looking at. Early in the cycle, there's a lot of extra information that prediction markets are able to speculate about what will happen during the course of a cycle and leads to much lower errors than you're going to get from poll-based forecasts. Okay, fifth thing that we did in 2012, combinatorial prediction markets. So the prediction markets, public prediction markets weren't ready yet to ask complicated questions, so we did so ourselves. We set up our own prediction markets, recruited contestants, and asked a bunch of questions about the probability, the joint probability of different events occurring. As I said, there's 2 to the power of 51 possible outcomes that can happen. And the cool thing is that in 2008, we literally could not have run this at all because it was simply computationally too expensive. So this is a question we wanted to know, and we would have wanted to know, but it was literally just too difficult to do because you essentially have to have a back-end data structure that is keeping track of 2 to the power of 51 possibilities, and anytime anyone queries a set of things, so in this case, a bunch of swing states going in a certain direction, the system then needs to give back a price and say, do you think this is too high or too low? So would you buy or would you sell or would you do nothing, right? And in order to do that, it needs to actually compute that, and that just simply was impossible to keep track of in a consistent way. But by 2012, we finally had the essentially processing power to be able to have that many predictions in essentially a matrix and then be able to query them and then update all of the predictions based off of any predictions. And so that's actually the really hard part, which is essentially to say, so someone then buys this, what does that mean to all of the single state predictions for Ohio and Pennsylvania and Virginia, and then all of the other combinations just of those states, and then what does that mean to every other set of predictions as you spread out further and further from the contract that people purchased. And so this was really exciting work to start thinking about how we can handle those questions. And we saw that the respondents actually did provide things that looked useful. So a lot of different questions we had, in which were combinatorial questions. We were creating histograms based off possible outcomes, and you can see what we had initialized the system as and where ultimately things converged to. with a bunch of play users just playing around in the markets. I'll touch briefly on online and browsing and social media data. So we didn't really think of this as prediction as much as trying to understand what the data was and what was useful. Now, to be clear, at the time, a lot of people were looking at these as predictions. They're putting out raw search or raw browser data as an indication that something may or may not happen. As I would have joked then and would now, that if you looked at Twitter in 2012, then you would have been very certain that Ron Paul was going to run away with the election because he really, if you guys remember him, his son's in the Senate now. But we did a lot of data analysis to try to understand what we were getting, at least, from this data. And one of the works, which is actually with Jake Hoffman, who will be speaking later, we were looking at Twitter and search data to just understand how not just it wasn't non-representative, and this continues to be the case, and because you may hear people say, Twitter's not real life, right? That's a really important thing to remember. That at the exact times that you need this type of data, it shifts dramatically. And this actually still holds in some ways, and it is really interesting. And one of the kind of fun things we saw from that, what you see here is a chart in 2012 of tweets, and actually, yes, I pulled the wrong things. It's just tweets. I apologize, I pulled the wrong figure note here, because this is a search of tweets, and it's a search of the percentage of tweets that had URLs attached to it. Okay, so this is actually the timeline from August through Election Day, and what you're seeing here is the percentage of tweets that had a URL on the tweet if it talked about Obama or Romney, or talked about both Obama and Romney. And what you're going to see is at the during the debates, if you look here, here, and here, and then Election Day, and then earlier on as well, you're going to see these massive drops on days of high activity, and so. Where essentially you go from a resting of about 65% of tweets, including URLs, to like 20 or 15%, including URLs at a given time. And what you should take from this is that it's not just that you have people who aren't representative online, because we can handle that. We can deal with how people look as far as make them representative of a target population. And it's not just that different people are engaging at times of high information flow, who then look different than the people beforehand. So if you compared at one time to another, you're going to get a different group of people. They're actually also engaging very differently at the times that you would ultimately care about. And so if you're trying to track things and trying to make predictions, and especially thinking about online and social media data as a way to make predictions quickly with low latency because it's always on, you're going to end up running into a lot of troubles in which if you made predictions or made models based off of steady state, the times you actually need them, you have a very different situation going on. Different people doing different things, responding to essentially a different question. And if you kind of jumped into this data, and we did so again in 2016 in some ways, what you're seeing is that essentially people are just responding to a different thing. They're providing an answer to a different question. And so if you think about it in a predictive sense, it becomes a very bad survey to use. So this was some of the things I talked about in 2012 when I was thinking about fundamentals, doing new analytics on polling, new questions on polling, using prediction markets just straightforward, using combinatorial prediction markets, thinking about online search data. Some of the things that evolves to in 2016 is a little different. First of all, kind of questions become a little more evolved. Thinking about much more about subgroup demographics and geography, thinking about how we mix this data. So roughly in 2016, I was thinking about kind of two sets of predictions basically that we were using. One was an aggregate of a bunch of different public prediction data, and the other was a bunch of experimental data together. What I refer to as RDE plus Dynamic MRP, which is the type of data collection and data analytics we're using on non-probability polling. And then a bunch of different control variables we'd adding dynamics, using different administrative data that helped us understand things, and thinking more about online data not as a prediction, but as an outcome variable. And so actually, I didn't want to draw the talk away too far from it. I would say that in 2016, if people want to ask, we were using search data and we're using Twitter data as essentially like an impact for TV consumption, so saying how much people were interacting with different types of things. And rather than thinking of it as a prediction variable, we were thinking really, this is a great low latency outcome that people may want to care about. So prior to the 2016 election, I thought very hard about how to start combining some of the public data. What you're going to see here is, so this is the mean squared error. This is looking at elections from 2006, 8, 10, 12, 14 in a paper that I put forward in 2015. And so it's a couple hundred observations, and this is a mix between Senate and presidential. You're basically looking at the mean squared error of probability of victory for a bunch of different state level races, judging by days before the election, so up to 130 days before the election, models that are exclusively built on fundamental data, polling data, and prediction market data. A few things to note here is that the error from the fundamental model doesn't change because my fundamental model doesn't include additional data as we get closer to the election, so it is the same by definition. There is a slight advantage to the prediction market data, especially earlier on, though it does bounce around. And then ultimately, especially in the last month or so, the prediction market and polling data does converge. And the thing that people were, that we were doing, and I guess other people also thinking a lot about, what I ended up building here is a combinatorial model, combinatorial is not the right word, it's a combined model, in which I looked at all the data and said, what's the best way to combine them together? And ultimately, it's a kind of a Bayesian updating experience in which I start with the fundamental model. It's a good place to start. And then as polling data and prediction market data evolves, it essentially updates the prediction each day. So that's the best way to think about it. So you start with a baseline, and so if the data is very thin coming in, the fundamental model will continue on to have a much larger impact later into the election cycle. If you're especially in a state in which there aren't prediction markets and there aren't polling, basically, the fundamental model becomes the prediction at the end. That's great. For states in which there is a lot of data flow coming in, tons of polling, tons of prediction markets, ultimately that just updates and essentially the fundamental model kind of disappears when it comes to impact. I should note that this is not the same for if you care about vote share. And so some stakeholders care about some things, some stakeholders care about other things. If you're a campaign, if you're thinking about allocating resources even as an investor, maybe you care about probability of victory, but maybe you're a very suave person, you care a lot about vote share, especially among some demographics. Prediction markets do a terrible job in predicting vote share because if a candidate's going to win by 5 or 10 or 100 points, they're still going to have basically the same probability, so there's not much discretion there. Poll-based forecasts have the ability to do much better, and essentially a good prediction of vote share is going to come off of the polling data. We did put forth the same fundamental model by itself, though, just so people can see it. I put this out on February 28th because I wanted to do it in February again. So I'll do it again next February. At the time, and I just redid the chart here so you can see which states went which way. And so there's going to see two columns, the fundamental model by itself and what the aggregated prediction was showing at the exact same time. So the prediction market and polling data is included on top of the fundamental data here. And what you'll see is that the generic Republican was doing better than the generic Democrat. The generic Democrat at the time, I guess, was, and the generic both not clear who they were going to be, but ultimately the Democrat that people thought was going to be was doing better than what they thought the Republican would be, in the sense that the polling and prediction market model was taking all the fundamental models data and looking a little more democratic than what the fundamentals do. And so in pretty much, I think, every case here, the PredictWise column is higher for the Democrat than it is for is in the fundamental model. The fundamental model would have had 292 to 246 for the Republican. Ultimately, obviously, I didn't put much stock into this because I was looking at the combined model. So at 46 out of 51, pointing in the correct direction as well. This is what the combined model looked like on the night of the election. It also had 46 of 51 pointing in the correct direction, but unfortunately for polls and prediction markets, things had shifted heavily towards Clinton versus Trump, insofar as all 5 states that were wrong were Democratic, were noted as Democratic but went Republican. And so ultimately, people can judge, this versus this, but on a state-by-state level and on a mean square error, they're somewhat comparable. But obviously, on what it denoted aggregate, which I'll get to in a second, the media is going to would have treated me like a god here and a goat here. That being said, one thing that, and I'll touch on this a little more later, that is all about how we think about the combination of the data, obviously, because that is all about the Electoral College and not about the individual predictions. But one reason why people also, beyond what we've seen, I think more in terms of the, not as favorable towards fundamental models in the long run, is this is a really interesting chart. This is Gallup's presidential approval going back to Truman. And one thing that is just really clear and distinct is you're going to see a lot of variability, and then it just starts to taper off pretty heavily under Obama. And Trump is comparatively like almost a straight line. And so there's another chart which I could have put up. Lynn Varick out of UCLA has a really nice chart. She shows that this is a product of something too. Is you look at the correlation between economic variables and presidential approval, and it is like highly correlated, and then it just like slopes to like 0 under Obama, right? And so a lot of the models are built on presidential approval, economic indicators. We do need to worry about how much these correlations on very low observations will last moving forward as partisanship shifts this relationship. At the same time, using public data, I was also building out private things. Rather than using Xbox, we're using something called RDE, which is random device engagement, using data from a bunch of different companies, Civic Science and Pollfish being the ones that I'm most tied to. Think of these as the landlines of the future. This is a way of using native applications, native ads inside of applications. And this is essentially, if you think about people's cookies or mobile-based IDs, this is essentially, rather than calling them up on a landline, this is how you randomly engage people on a mobile phone. It looks something like this. Here's the math. And I'm happy to talk about this in detail later, but this is what dynamic MRP looks like. So this is an update of what we were doing in 2012. And basically, we're just building a model in which we throw in a bunch of the demographic data that describes people, gender, age, education, race, marriage status, party identification, urbanicity, district level data. And we essentially run a model that says, okay, conditional on all of these variables, what is the probability that they answer a poll in a certain way? And then we say, okay, now that we have created hundreds of thousands of essentially clusters of demographics and said they're this % likely to poll for one candidate or another or answer a question this way or another, we say what percentage are each of those clusters in the target population that we care about? Basically, in this case, what we're going to do is we're going to build a model based off of a combination of the voter files and the census, which is going to allow us to say what percentage of any given group in any given geography do we expect for the voting population. So for example, how much do I expect lower educated white males between the ages of 18 and 24 in Georgia as a percentage of the population? I'm going to take the percentage that they're going to vote Clinton, the percentage they're going to vote Trump, and I'm going to just multiply that out. One of the key things there is that, which I'll talk about in a second, right towards the end, is that there's a big trade-off here between how well do I want to predict the group, so how much do I want to predict that group versus any individual in that group. I'm squashing the variation within that group. I'm literally squashing it to almost 0, right? So I'm not allowing any variation within that group, but maybe I know some things that I can pick up, and that's kind of, I think, the key task in 2020, because I am building these models off of voter files. voter files are a list of essentially every registered American plus a good percentage of the non-registered Americans. There's about 20 to 30% of Americans who, for various reasons, are not included in the voter file. And then, of course, the census allows me to understand the whole population. Other things that we were doing and thinking through is essentially how we build dynamics into these models. And this becomes very important for a lot of questions in which you now have repeated data with extremely low latency, but also high repetition, and how much you want to update models based off new information or not. And we had to make a lot of decisions about this. And what we end up doing is you essentially imagine, the easiest way to think about this is we're running a model on day t equals 0, and then we're essentially pulling those coefficients from the model forward, and we're going to allow them to vary a reasonable amount. But this is not something that I say is extremely well-founded. It's something that we're continuously tinkering with. We controlled for a lot of variables that public polling would not be controlling for. This was from 2012 data, and this is the reason why. We show on the left, this is the two-party Obama support when we do not control for party ID. And what happened was after the October 3rd debate, public polls plummeted for Barack Obama and then came back up. But you can see at the same time, we were asking people for their vote, but we were also asking for their party identification, which we were already controlling for. And what we saw was that there's just this huge drop in the percentage of Democrats who were answering our polls conditional on all other demographics. So even looking the same as far as age, gender, race, education, et cetera, there were just less Democrats. And what this means is that even though we were controlling for tons of things, if you didn't control for party ID, you weren't capturing the essentially sad Democrats who, in the same bucket, weren't showing up to answer polls the day after Obama looked bad, and similarly may not have been Republicans who may not have been showing up when Romney looked bad. This is a partisan non-response. It became something that a lot of other people started thinking about, but we kind of pioneered coming out of 2012, and it led us to control for things like party ID. I'll add one more thing. A lot of things you'll hear about in this election, education. If you look on the left, you'll see that there was very, very small difference between education conditional variables for who people voted for prior to the 2016 election. So a lot of people were hit really hard for not controlling for education, but it was actually, it just wasn't that big a deal prior to the election. The methods that we are using don't cost us that much to control for things. The best way to think about it is the standard public methods have a huge penalty for every variable you control for. You lose a lot of power in your things, and so that's why they're not very good at sub-demographics, and that's why they don't control for them. We put a lot of things forward. This was in the New York Times showing Donald Trump would win Florida by 1. The interesting thing here is this shows analytics. We were handed the same data as 4 other pollsters, took the same data and just ran our analytics, and had Trump winning by 1 while everyone else had Clinton winning. Trump ultimately won Florida by 1. This was a map that we had on MSN data. As you see, we had the upper Midwest trending towards to Trump. This is the full map that we had publishing daily on Pollfish's website and among other places, with a really tight presidential election, and then obviously, as you can see here, Florida and the whole Rust Belt, except for Michigan, going towards Trump. We were putting this out. I was assuring people on Twitter that this was experimental. I'll regret that for the rest of my life. No concern at all. You know, experimental. We don't want to think too much about it. I didn't want to confuse people with the public data and the private data and blah blah blah. So there we have it. But you know, tying back to the first part, the really interesting thing is beyond this data being quite accurate is that, and here you can see Clinton vote share and the expected vote share, and it did quite well, is that the errors that came out of this methodology tend to be uncorrelated. And this is really important. So if you look on the left here, this is pollster.com's aggregate of traditional polling, and this is ours. Our error was actually very, slightly larger than what you're getting from traditional polling. And so you can think of this as kind of what was leading people to see Clinton as winning, is because you essentially had to assume a perfectly correlated error for her to lose, because all of these states had to go at once. And high correlation is very true, and it actually is very true in the data. In the data that we were creating, we saw basically errors that went in both directions, which is really good when you need to make combinatorial predictions, because your error is not correlated. You're going to have, you're actually not going to get hit by these massive waves that go in one direction or the other. We actually saw this again in, just jump forward. We saw this again in 2018 using the exact same sort of data methodology, where you see the pollster error on the left, and you see our error on the right. Again, actually slightly larger error. We have a, this is experimental, it's kind of low cost, but the error is uncorrelated across, this is all across all 435 House districts. And then I showed this against Civis, which is the main polling company for the Democrats. Again, we have ultimately almost an uncorrelated error structure, and this is actually really good for making predictions and not getting caught in things. Some of the other things, which I have just a few more minutes to say, this type of method allows us to speed up latency and answer some more interesting things. This was a poll 1 week before the Montana special election in 2017, where we had a Republican up by 13. The day before the election, that Republican punched a reporter. And then we went in the field just the next day, showed it closing the gap by about a half. A lot of people had voted early already. This actually did make a difference, and this ultimately was within a half a percentage points of the true answer. And then I'll just kind of touch briefly on some of the things we're doing moving forward. Thinking a lot about, this was an article which I wrote in the Times right before the 2016 election, about how to think about margin of error. We really want to think about on the consumption side, people not thinking so deterministically, but thinking probabilistically. That's very complicated. But so we've been building out structures to show, well, what happens if you start actually allowing people to see, as you move, essentially turnout in various reasonable ways, you can actually see the maps shift. So rather than thinking about probability in terms of this number that is very confusing, you can actually start playing with what probability means. Kind of updating on some of the dynamic voting stuff, pulling in early voting data, and I'm not going to go into details because we're running out of time, but we're building out models that we started testing in 2018, and we'll do that in 2020, in which we pull in voter file data in real time in order to update the post-stratification space. And what this means is that previously, because computationally it's just absolutely impossible probably in 2016, we essentially created a post-stratification space that we updated once a month, which means that we were modeling daily who people were going to vote for, conditional on the demographics, but who was going to vote, we were keeping static and updating once a month based off of an updating inflow of the voter file, which is massive. It's 250 million rows. Now you actually have the ability to bring this data in on essentially nearly daily basis. If you wanted to update it based off of early voting and to update dynamically, not just who you think is going to vote, but you can use that data of early votes to help better understand who people are going to vote for. And then I'll add with 3 more slides, personal, moving a lot of things from aggregate predictions to personal predictions. You can think of credit files and voter files as essentially a massive sparse matrix. And so rather than predicting 30 to 44-year-old white males in a certain area, you can start predicting how Jake's going to vote. You could do thinking about mobile. Mobile provides massive lists of essentially everyone, which you can think of as comparable to a voter file in a sense. And this allows us to extend out and think about who's missing from these voter file lists and credit file lists, help fill in the rest of the grid, and use that both to capture people in surveys, but then also to then figure out who people are and exist. And then thinking, finally, I'll say interacting in the space, so pulling back to some of the earlier stuff we were talking about with online data, and bringing all of this together is that we're doing surveys in the same space that people are launching ads. This allows us to think about both running essentially ads and then surveys and ads and surveys and have an interactive experience, understanding how people are affecting things on a smaller scale to think about ad effectiveness, but on a larger scale, kind of combining this data to better understand the interplay between campaigns and essentially public opinion. And thinking about predictions has now moved, in my mind, from this thing that you're looking at a deterministic world to this interactive predictive experience where you're really predicting public opinion and then ultimately iterating over it multiple times in a cycle to better understand essentially what's happening by the campaigns and by people. And so I will leave it there and turn it to the next person.
Clarification.
Yeah.
As I understand it, in 2016, your final prediction was an 89% probability of a Clinton win.
That's correct.
Thank you for that very provocative talk, David. I have a question that I would save in detail for our panel session later, but maybe you and Ellen and our other speakers can start to think about it. Since you have so much detailed data, can you begin to, well, maybe we can have your thoughts on how you detect foreign interference with our election cycles. Speculative, but you have so much data, I can't believe that some of it is going to be helpful for that purpose. Anyway, a question for the panel session. Thank you very much.